Hi. In my previous video, I gave you sort of like a summary of the things that you need to know and the concepts that you need to understand with sequences and series, aka number patterns. Okay, so what I'm going to be doing in this video is just going through some typical exam questions. Now, obviously, I will not be able to go through every possible exam question on sequences and series. So I just chose a few questions that are a little bit more challenging, that I feel are a little bit more challenging. And yeah, we're just gonna go through those questions. Okay, so please don't forget to follow me on my Instagram because from time to time I will be posting like some of those non-routine, difficult questions and solutions on my Instagram page. So please follow me, and if you need more exam coaching, like if you want to go through more exam papers and you need someone to kind of coach you through that, you can just drop me a quick email. And yeah, please, if you found this video helpful, then please like it and please subscribe to this channel if you haven't done so, and click on the notification button so that you can see every new video that I post. Okay, so let's just quickly get into it then. Okay, so we're gonna start with a question on quadratic sequences. Okay, so we've got this question. This was question 3 in the national exam of November 2022. Okay, so it reads, it is given that the general term of a quadratic number pattern is that, and the first term of the first difference is E7. Okay, so the first term of the first difference is 7. So now they want us to show that B is equal to 4. Now let me just demonstrate something first before we quickly work out the answer, because the answer is actually pretty straightforward, but there's something that you just need to remember. Okay, so remember, in a quadratic sequence, we've got our terms. So T1, T2, T3, T4. Okay, and the first differences. So now we told that the first term of the first differences is 7. So that means this one minus that one should give us 7. Okay, we don't know the difference there. We don't know the difference there. And the second term, we don't know the difference. We don't know the difference. But what we do remember is that on the first level, we use the equation a plus b plus c. On the second level, we use 3a plus b. And on the third level, we use 2a. Okay, so it's kind of now obvious to see that 3a plus b should give us 7. Now we know what the value of a is. It's 1 because that's the coefficient there. Okay, so what this means is that 3 times 1 plus b is equal to 7. And just take the 3 over, then b is equal to 7 minus 3, which is equal to 4. Okay, so that is what you get 2 marks for. Alright, now the next question is to determine the value of the 60th term of this number pattern. Okay, so we're just gonna bring out our calculator quickly, because what we're going to do is that in our equations that we had before, we now know that b is 4. So now we now know that our general term Tn is equal to n squared plus 4n plus okay, this is plus 9. Okay, so that was our general term. So obviously the 60th term, we're just gonna substitute 60 into there. Okay, so plus 4 by 60 plus 9, and then just quickly do that in the calculator and obtain an answer. Okay, so we're just gonna do that quickly in the calculator. All right, so that is going to be 60 squared plus 4 by 60 plus 9. Okay, so that's 3,849. Okay, so that one was pretty straightforward. Okay, now they want us to determine the general term for the sequence of the first differences of the quadratic number pattern. Okay, now if you look at the original number pattern that we have there, all right, let me just bring back that number pattern quickly. to the next because there's something that I just need to show you over here. Okay, so this is the sequence of numbers. Okay, now what we can see is that if a is 1, okay, then remember your second differences should be 2a. Okay, so we know that a is 1. So 2 times 1 will obviously give us 2. Okay, so what that means therefore is that the second common differences for this particular sequence is 2. Okay, so 7 plus 2 will give us 9, plus 2 will give us 11. So as you can see, this is an arithmetic sequence. Okay, so that makes an arithmetic sequence with the first term a being 7 and the common difference being 2. So now we're just going to bring in our arithmetic sequence formula. Okay, this one here that we talked about in my previous video. All right, so a is 7. Okay, a is 7. Okay, so n minus 1. Oh, sorry, the common difference is actually 2. Okay, not 7. All right, so let's just simplify that quickly. Okay, maybe I can just bring that down to make space. Okay, so that is going to be 7 plus 2n minus 2. Okay, 7 minus 2 will give us 5, so that means Tn. Oh, but they gave us a format here. Okay, they want us to give this sequence in terms of p. Okay, so we're gonna keep that format. Tp is going then to be equal to, instead of saying 2n, we're gonna say 2p plus 7 minus 2, which is 5. Okay, so that is the general term for that particular sequence over there. Okay, now which two consecutive terms in the quadratic number pattern have a first difference of 157? Okay, so you can see T1, that will be the term, T2, that will be the second term, T3, that will be the third term. So now we need to find which term is term number 157. Okay, so we're just going to do what we did in the previous video. Take this 2p plus 5, make it equal to 157. And let's solve this quickly. So 2p is going to be equal to 157 minus 5, which means 2p is going to be equal to 152. Okay, divide both sides by 2. Okay, so p is going to be equal to, okay, bring the calculator, 152 divided by 2, that gives us 76. Okay, so that is going to be the 76th. So what that means is that this is going to be between the 76th and 77th term. Okay, so that is basically how you go through that question over there. Okay, now let's look at a question on arithmetic sequences. All right, so the question that I have here is from the November 2021 exam. Okay, it was question 4 in that particular paper. Okay, so we've got a linear pattern 5, 7, 9, and so on and so on. So determine term number 51. Okay, that one's pretty straightforward. Okay, because you can already see that this pattern has got a common difference of 2. Okay, and we already know the first term. We already know the formula for the general term of an arithmetic sequence. So all you're just going to do is substitute the first term and the common difference in there and get the general term. Okay, so a is 5, right? A is 5, n minus 1, and the common difference is 2. So let's just simplify that. So 5 plus 2n minus 2, which becomes the 2n, and 5 minus 2 is 3, so 2n plus 3. So finding term number 51, we're just going to substitute the 51 into the general term. Okay, so 2 times 51 plus 3, We can just quickly do that in the calculator. So that's 2 by, okay, just go like that, 551 plus 3, okay, and our answer is 105. Okay, that was a pretty straightforward one. And the second one is also pretty straightforward. We just need to calculate the sum of the first 51 terms. So we're just gonna recall our sum of arithmetic series formula, okay, n over 2 by 2a plus n minus 1 times the common difference. Okay. Um, so here we know that we're summing over 51 terms. 2 times the first term is 5 and n is 51, and the common difference is 2. Okay, so we're just gonna quickly do this on the calculator. Alright, so we're just gonna say, okay, 51 over 2, okay, open bracket, 2 by 5 plus 51 minus 2 times 2, close the bracket, equals, and then we get 2754. Okay, so those are two pretty straightforward questions. All right, now say write down the expansion of this sigma notation. Okay, show only the first three terms and the last term. Okay, so we're just gonna bring our calculator and find the terms. Okay, so our n is starting at 1, so that means we're just gonna go into our calculator, take this general term. So 2 times n is 1, okay, plus 3, okay, so that's 5, okay, and then the next term we're just gonna come here, delete, replace 2, okay, and then that's 7. Says first three terms, so let's find the third one. Remove 2, put 3, and it's 9, okay, and they said and the last term, so the last term is obviously term number 5000. Okay, so we're just gonna come here, replace that with 5000. Okay, so that's 10,003. All right, so that, yeah, basically that's what gets you 1 mark. Okay, so that one was also pretty straightforward. You just need to understand how to work with your sigma notation. Okay, so hence or otherwise calculate that in there. Okay, so what we're going to do is we're just going to find the sum of that using our sum of arithmetic. And then, okay, but now because we know that pattern already, let's expand this second pattern here. Okay, so let's expand that because the first pattern we kind of know that one already. So the second pattern, it's n starting from 1 up to 4999, okay, of negative 2n minus 1. Okay, so let's find the first three terms of that. Okay, so we're just gonna bring up our calculator. So let's find the first term of that. So that will be negative 2 by n, so n is 1 in this case, minus 1, okay, so that will be negative 3. So let's check out the next one. Now come here, remove that, and put 2, and that's negative 5. And the third term, okay, so come here, put 3, and it's negative 7, on and so on. Okay, we can find the last term, no problem with that. So we can just delete, put 4, okay, 4999, and that will be negative 9999. Okay, so now what we're going to do is we're going to find the sum of this series and the sum of that series and add them together. Okay, so let's find the sum of this series first. Okay, we're just going to use our sum of arithmetic series formula. Okay, from 1 to 5,000, that is 5,000 terms. Okay, by 2 by the first term is 5. You can see it's adding 2 the whole time, so the common difference is 2. Okay, so we're gonna say plus 5,000 minus 1 times 2. Okay, so we're just gonna quickly do that one in the calculator. Okay, so 5,000 over 2, open the bracket, 2 by 5 plus 5,000 minus 1 times 2. Okay, close the bracket. Okay, so we got that massive number. Let me see. Okay, so that's 25,020,000. So 25 020,000. Okay, now let's find now the sum of this one. Okay, using the same formula. All right. So the sum of that other series, it's n equal to 1 up to 4,999 terms. Okay. Uh, 2 by the first term, you can see it was negative 3 plus we summing this over 4,999 terms with the common difference of, okay, we're subtracting 2 the whole time here, so the common difference is actually going to be a negative 2. Okay, now let's do this in the calculator. Okay, so we're going to say 4,999. Oh, okay, over 2, open bracket, 2 by negative 3 plus, open bracket, 4,999 minus 1 times negative 2. Okay, close that bracket. Okay, so that is negative. Okay, how many nines? Okay, 6. So that's negative 2, 4, 9, 9, 9, 9, 9, 9. Okay, let's just check if that's the right thing. Okay, yeah, it is. So now we're just gonna add these two. Okay, so 25,020,000 plus, okay, which means we're gonna subtract, but it's fine, you can enter it like that in the calculator just to pick it up. Okay, and then let's just do that quickly in the calculator. So 25,020,000 plus, open bracket, negative 24,999,999. Okay, close bracket, which means our answer there is 20,001. Okay, so that is the kind of exam questions you can get. And yeah, let's move on to the next question. Okay, so let's move on now to geometric series sequences. Okay, and series. Right. I'm just gonna take this question here. Okay, this is a question from the February March 2017 exam. Okay, so it's this question that we have right here. So we've been given the geometric sequence. Okay, that one there. So now they want us to calculate the possible values of b. Okay, so because this is a geometric sequence, what it means is that in every geometric sequence, you must just remember the ratio of T3 divided by T2 should give you the result is the ratio of T2 divided by T1. Okay, so now in this case, T3 is negative 1 over T2, which is B, should give me the same result as T2, which is B, over T1, which is negative 1 over 4. Okay, so let's just cross multiply these things both sides. Okay, so if I cross multiply both sides by negative 1 over 4 and negative 1 over 4, what it means is that I have 1 over 4 by b being equal to oh sorry, b is in the denominator. Okay, so negative 1 over 4b. Okay, now if I cross multiply the b again, that means 1 over 4 becomes equal to b squared. So just take square roots, which means b is going to be equal to a positive or negative 1 over 2. Okay, so the possible values of b is therefore either a negative 1 over 2, or b becomes a positive 1 over 2. Okay, so it can be one of those two values right there. Now, question 2.2 is now saying if b becomes positive half, find the 19th term of the sequence. Okay, that's a pretty straightforward question now, because what it means is that our sequence that we have is negative 1 over 4, then we have positive half, then we have negative 1, and so on. Okay, so it's easy to kind of notice that our common ratio, okay, r is going to be simply negative 1 divided by positive half, and that means we are multiplying everything by a negative 2. Okay, so that's a common ratio, and we know what a is. So the general term t of n is going to be equal to negative 1 over 4 times negative 2, okay, to the power of n minus 1. So term 19 just becomes negative 1 over 4 by negative 2 to the power of 19 minus 1, which is, we're just going to do in the calculator. Okay, so that's negative 1 over 4, okay, times, open bracket, negative 2, close bracket, to the power of 19 minus 1, and that is negative 65,536. Okay, so if b is equal to half, write down the sum of the first 20 positive terms of the sequence in sigma notation. Okay, so first of all, let's just write down the full sequence and then derive our sequence from there. So it's negative 1 over 4, and then a positive half, and then a negative 1. Remember, our common ratio is negative 2, so that means this is positive 2, then that's negative 4, and that's positive 8. So let's say they want the sequence of positives. Okay, so that and that and that. Okay, which means our new sequence that we now have is half, and then 2, and then 8. Okay, so this is quite a straightforward sequence. Okay, with the common ratio being equal to 4, the first term being equal to a half. So which means our general term for this sequence is going to be a half times 4 to the power of n minus 1. Okay, so that's what this sequence is going to be. All right, maybe it will be better for you to write that as a summarized form. So let's just simplify that, because I think that is simplifiable. Okay, so a half is the same as 2 to the power of negative 1 by the laws of exponents, and then this is 2 to the power of 2 to the power of n minus 1. So that becomes 2 to the power of negative 1 by 2 to the power of 2 by n minus 1. Now same basis, so we can add the exponents. So 2 to the power of negative 1 plus, we can remove the brackets already, 2n minus 1, which means this is 2 to the power of 2n minus 2. Okay, so now if we're gonna write this in sigma notation, okay, we're gonna be summing from n equal to 1 up to 20. This expression is 2 to the power of 2n minus 2. Okay, that's all we are needed to do. We haven't been asked to find the sum, so we're not going to find the sum. So now the question now is that series convergent? Now remember, we said series are only convergent, okay? They're only convergent if and only if r is between -1 and +1. Now without r that is equal to 4, then surely it's not a convergent sequence, okay? So the sequence is not convergent. Okay, not convergent is the common ratio is definitely greater than 1. Okay, so that is why it's not convergent. Okay, so let's just quickly go through an exam question that includes the concept of convergence and sum to infinity. Okay, the question that I've chosen for this is from the November 2020 exam. Okay, question 3. So it says prove that the sum there is a convergent geometric series. Okay, so if you have to prove that a series is convergent, what you want to do is you're required to prove that the common ratio is between -1 and +1. Why? Because sequences only converge when that happens. Okay, so remember, sequence is only convergent if and only if r is between -1 and +1. Okay, now let's quickly expand the series and find the common ratio. Okay, so for that we can just take out our calculator and expand that. So from k equal to 1 up to infinity, or 4 by 3 to the power of 2 minus k. So let's find the first term. Okay, so we're just going to say 4 times 3 to the power of 2 minus k is equal to 1, so let's put 1 there. Okay, so that's 12. Okay, next term, replace the 1 with a 2. Okay, then that's 4. Then the third term, place the 2 with a 3. Okay, okay, maybe we can find term number 4 quickly. Okay, so here's term number 4. All right, now remember, if you divide any two consecutive terms, you get your common ratio. Okay, so our common ratio can be this one, 4 divided by 12. Okay, and if you simplify that fraction, it is 1 over 3, which definitely is less than 1. Okay, so therefore the series, sorry, is convergent. Okay, as 1 over 3 is between -1 and +1. Okay, so we've just proved that that sequence is convergent. Okay, okay, so question 3.2, if this is equal to 2 over 9, determine the value of p. Okay, so if you look at this series here, is the same one as the one that we proved is convergent before. So for that series, we know for sure that the common ratio is 1 over 3. Okay, now the first term of the sequence, that if you look at it, it's starting from p. So that means you're going to substitute p into that. So the first term of the sequence is 4 by 3 to the power of 2 minus p. Okay, now if you recall, the sum to infinity of a convergent series is given by the formula a over 1 minus r. Okay, so in our case here, this is a, so 4 times 3 to the power of 2 minus p is a over 1 minus, we know our r is 1 over 3, and that should equal 2 over 9. Okay, So let's now simplify that. Okay, so 4 by 3 of 2 minus p over 2 over 3 is equal to 2 over 9. Okay, you can cross multiply both sides by 2 over 3. Cross multiply both sides by 2 over 3. Okay, so that you cancel. So 4 times 3 to the power of 2 minus p should be equal to, okay, you can just quickly work that on the calculator. Alright, so that's 2 over 9 times 2 over 3. Okay, so that will be 4 over 20. Okay, divide both sides by 4, divide both sides by 4, let's cancel. Then 3 to the power of 2 minus p will become 1 over 27. Okay, then 3 2 minus p becomes equal to 1 over 27. We know that is 3 to the power of 3. Okay, now let's write it in proper exponential form. Then 3 to the power of 2 minus p is equal to 3 to the power of negative 3 by your rules of exponents. Same base, so 2 minus p is equal to negative 3. Let's take the the 2 over, so negative 3 is p is negative 3 minus 2, which means negative p is equal to negative 5. But now because both the negatives, that means p is equal to 5. Okay, so now we've just found the value of p. It's equal to 5. Okay, so this is all that I have for now. Okay, as I said in the beginning of the video, it's not going to be possible to go through every possible exam question on sequences and series in one video because that's going to be too much. Okay, but you can follow me on my socials, on my Instagram account at Rasamukondwa. Okay, and if you're going through more past exam questions and you need a little bit of coaching or tutoring, then quickly just drop me a quick email and we can talk about that. And if you found this video helpful, please like it. Okay, and please subscribe to my YouTube channel and click on the notification so that you can see notifications of all the other videos that I'm going to be doing. So for now, this is the end, and thank you for watching. I'll see you next time.